Okay, but we are doing 3.1 today. We got about 30 minutes to get as much done as I want, so. Okay, have you guys done exponential functions in the past? Maybe a little bit in algebra 2. Okay, like always, I'll pretend like we haven't seen it. We're gonna do some really basic stuff today with our exponentials. But first, we're going to decide if it's a power function or an exponential function. So a power function versus an exponential function is just one key difference. A power function is all the stuff that we were doing before. It was when we have x raised to some number. X to the second, x to the third, x to the 200th. Those are all power functions because x is being raised to that number. Exponential is going to be some number raised to the x. So in the exponential function, x is my exponent, okay? So we're going to label these 4 functions under here as power function, exponential, or neither, okay? So the first one, y equals x to the 8th. What do we think that is? Power, very good. What about letter B, y equals 3 to the x? Exponential, very good. I'm just going to abbreviate exp. What about y equals 4 squared? I'm going to say neither. I don't see x anywhere. And for the next one, it's y equals x raised to the x. I'm going to say neither because it's in both spots and both isn't an option. So we'll say neither. So that's something different. Okay. Now, number 2, we're going to find the value of the function for the given x values, and we are not going to use a calculator. So I need you to kind of remember, what do we already know about exponents, okay? So we're going to plug in a different x for each one, and we've got a different equation for each one as well. So the first one says x is going to equal 0. So I'm going to have 3 times 5 raised to the 0. What do I do first? Do I do 3 times 5, or do I do 5 to the 0? 5 to the 0. 5 to the 0. What is 5 to the 0? 0. Nope. 1. There we go. 3 times 1. 3 times 1 is just 3. Okay, perfect. The fact that anything to the 0 power is 1 is going to be something we're going to use later today and later the rest of this unit. All right, the next one, now I've got a negative exponent. So we're going to decide what a negative exponent does to my number. 6 times 3 to the negative second. What does that negative second do to my 3? It goes to the bottom of my fraction. So essentially that's the same thing as 1 over 3 squared. And what is 3 squared? 9. So that's the same thing as 6 times 1/9. And you can simplify it here, or you can multiply them together and then simplify. We can do 6 over 9 and then break that down to 2/3, or you could have simplified it earlier. It doesn't matter. Either way, we'll get to the same answer. So exponent of 0 makes it 1. Exponent of negative makes it go to the bottom. It kind of flips that fraction for us. Oh shoot, the next one's an exponent that's going to be a fraction. Do you remember what an exponent that's a fraction does to my number? What does it do? A root. Very good, Neil. It makes it a radical. It makes it a root. Now, this number that's on bottom goes on the outside of the root. So it's like a root with a little 3 out front. So we verbally say the cube root or the third root. And then the number on the numerator goes on the inside with my number. It's still that power. So it's basically like 3 to the first. Now, 3 to the first is just 3, so that doesn't really simplify anything for us. So I've got -2 times the cube root of 3. Can you do the cube root of 3 by hand? What number cubes to be 3? You know? That's the other way around. Is there any number that cubes to be 3? No, I can't make that any simpler. It's going to be left as -2 root or cube root of 3. And that's as good as that one gets. And that's an okay answer. Okay, now this last one, it has a negative and it has a fraction. So we're going to do 8 times 4 raised to the -3/2. Okay. What does that negative do again to my? Moves it below. So I now basically have 1 over 4 to the 3/2. And what does that 3/2 do to my 4? I've got square root. So you could put that 2 out front. I'm gonna tell you though, that that's the same thing as having one X, it's just redundant, you don't need it. So I'll get rid of that eventually. And then that 3 though, that is gonna be my numerator. That's gonna go inside with the 4, so I am gonna have to do 4 to the 3rd power. Okay, so this becomes 8 times good root 64. And what is the square root of 64? 8. So it's 8 times 1 over 8. And so what's that going to be? 1. Very good. Oh, there's a lot going on. We're going to use that concept of these exponents as we go. So I wanted to kind of review them with some actual numbers here. Okay. All right. We're killing it. We just got 2 more problems left. Okay, this next one says, write the equation of the exponential function where f of x equals 3/2 and where f of -2 equals 108. Okay, these 2 problems are the same types of problems. These 2 problems are also a lot like the ones where I told you, find the linear equation of, find the quadratic equation of, find the polynomial equation of. So if you remember, we did linear functions and we used our generic y equals mx plus b. We did our quadratic ones and we did y equals a times x minus h squared plus k. Do you remember doing these? Okay, now this one, I have a generic formula for this one as well, okay? This one, my exponential, we're going to use y equals a times b raised to the x. Y equals a times b raised to the x. I need you to know that. I will tell you, we're not doing a quiz until after Thanksgiving break. So, but I will tell you, this will be a question on the next quiz that you take. Okay. Like I will ask you something like number 3, A and B. So you will have to know this little formula right here, which isn't that much, but I need you to know it. So let's break it down. A is basically your coefficient. And then B is the base of my exponential. X is obviously the exponent. So we need to find the coefficient and we need to find the base. Okay, we're going to do A because it's a little harder. We'll do that one together and then you'll try B on your own, okay? So we're going to use, bless you, we're going to use this y equals a times b raised to the x for these 2 problems, okay? And the reason I know to use that, it says write the equation of an exponential function. So that exponential function is a key off for me that I know that I need to use this formula. Okay. Now I gave us 2 points here. We've got an x, we've got a y, we've got another x, we've got another y. We're going to use each point one at a time. We use the point with the 0 first to help us find A. Then once we have A, then we use A and then the second point to help us find B, okay? So let's do the first part and you'll see why I like to use this first point to find A. So if I use my y equals a times b raised to the x, I've got 3/2 equals a times b raised to the 0. 3/2 equals a times b raised to the 0. Now what's b to the 0? 1. So what is a going to be equal to? 3/2. Basically, you can think of that as 1a, but like, would we ever write 1a? Yeah, it's like not wrong. It's just kind of redundant. At this point in our career, we don't really do that. Okay, so there's my a. Now we're going to use that a that I just found and this new equation to find b, okay? So I'm going to set up 108 equals a times b raised to the x. A we just found was 3/2, so I'm going to put 3/2 in here. And then b is going to be -2. B raised to -2, sorry. X is -2, b is raised to that -2. Say one more time. So now we're solving for b. Now looking at this a second time, there's another way that you can do this, but I'll just do what we did in F period today, which I think generally works fine as well. First thing you want to do is get rid of that coefficient. I want to move that a. How do I move a to the other side? We're going to multiply by that reciprocal. We're going to multiply by 3/2. You can think, or sorry, not 3/2, the reciprocal of it, 2/3. You can think of dividing by 3/2 if that makes sense to you, but I'm gonna multiply by 2/3 because that's gonna cancel this fraction out. And then I can get my calculator and I can do 2/3 of 108. 108 times 2 divided by 3, and I get 72. So 72 equals b raised to the -2nd. Okay. Now, if it was just b to the 2nd power, we'd be able to do a quick little square root and be done with it, but we can't here. What I want us to do is like go correctly through this all the way. Let's make that b be raised to a positive exponent. So let's deal with that negative. What does dealing with that negative look like? Move it to the bottom. Good. So I'm going to go 72 equals 1 over b squared. The easiest way of dealing with this is now making it a cross multiplication problem. So I can think of this as 72 over 1, and I can cross multiply 1 times 1 and 72 times b squared. I'm running out of space, so I'm just going to jump up here to write some more. Everyone's with me? 72 times b squared equals 1. Then what do I do next? How do I get b squared by itself? Divide by 72. So b squared equals 1 over 72. Now we're ready for some easy work to get rid of that square. What do I do? Square root. Okay, this is where it gets annoying, because they're all things that you can do, but it's irritating now because we cannot just leave it as root 1 over 72. We have to simplify it down, and we cannot have a radical in the denominator. Okay, what is the square root of 1? Good, so the numerator is just going to be 1. However, we have to do the square root of 72. If you have a fancy calculator that does it, awesome. If not, I'm going to make a factor tree. 72 breaks down into, we'll do 2 and 36. Oh, that's actually the easiest way, because now 36 is a perfect square, 6 and 6. And could you break 6 down to 2 and 3? Absolutely. But at the end of the day, I only care about the pairs that I have, and I've got a pair of 6s. So that means root 72 is the same thing as 6 root 2. Very good. Okay, we're not done yet. I cannot have that root 2 in the denominator, so what do I need to do? Multiply by root 2. Once I multiply by root 2, now I'm finally done. I get root 2 over 12. And the very, very, very last step I want to do is plug my a and my b into my equation, and then just have a generalized equation. Here's my b, root 2 over 12. My a was that 3/2. So I'm going to say y equals 3/2 root 2 over 12 raised to the x. Sorry, I got really messy there. That's our best answer. You cannot simplify, you cannot combine, you can't cancel anything. That's as good as it gets. Okay. I'm going to argue the one underneath it is also pretty easy. So can you try that one either by yourself or with a friend? In a second, I'll go put the answers on the board for that. Try the next one. It's the exact same process, but it's even a little easier. I have both my work for A and B on the board if you want to check those. And then my general equation will be here. It was a lot easier than the first one, wasn't it? But I want to do a harder one together with you, but I wanted you to do an easier one so you got the feeling of doing it by yourself. All right, feeling okay? Okay, last problem we're gonna do is number 4. We're gonna do some transformations. Okay. Before we do some transformations, we gotta remind ourselves what the basic exponential graph looks like. Do you remember from your BFF graphs, what was the equation of our exponential BFF? Y equals e to the x, right? And do you remember what that graph looked like?
Wasn't it like a giant one?
Yep, it popped up. And I don't remember if I stressed this or not, but it goes through the point 0, 1, and it always starts close to 0, and then it exponentially increases. It also has a horizontal asymptote at 0. So we would never cross it, but we get really, really close to it. Now, all of these graphs are based on the exponential graph of 2 raised to the x. That is not a very different graph from what we have right here. It might be a little bit steeper or a little bit flatter than our e, but I'm not worried about that, okay? So it's still going to be this generic shape that we're going to do each time. And all of these graphs come from this 2 raised to the x. And so we're just going to decide what the numbers or what the negatives do to change my graph. Does it flip it? Does it move it up or down? Does it move it left or right? Okay, and then we'll sketch it. So if I look at this first example, I've got y equals 2 raised to the x minus 3. What does that negative 3 do to my graph?
It's to the right,
Good, it shifts it to the right. How do you know that, Joe?
because it's a negative.
Good. And why does it not move it down? It's with the x, right? It's like us with. It's not lower, it's not with the real numbers, it's not doing anything to the y, it's up with the x, which means it affects the x going left or right. And when it's this negative, it does opposite of what we think it should be doing. Okay, so we're gonna move to the right 3. Instead of being at the point 0, 1, we're gonna move over 3, 1, 2, 3. Now we didn't move up or down any, so that means that my horizontal asymptote is still gonna be the same here at 0. And then I still approach that asymptote, and as soon as I hit that point, I'm gonna jump up. So we just took that graph and we just shifted it to the right 3. The 2 is part of the original equation, so that doesn't do anything for us. So don't worry about that. Okay, what about the next one? It says y equals 2 to the oh, sorry, Joe. Oh, you ready for the next one?
Yeah.
What's going on with this one?
Would you flip it?
We would flip it. Do you remember which axis we flip it when it's with the x? Do we flip it over the x or do we flip it over the y?
X.
You were right the first time. Y. Don't second guess yourself. It's opposite of what part it's with. So since it's up here with the x, you flip over. Sorry, I'm really trying to write kind of nice, but it's not looking like it. Flip over the x-axis. Now, so that means that we're still going to take this point. We're flipping over the y. Did I say x? You said y first, and I said y. I was right. Okay, I'm so sorry. It's one of those days. Over the y. Are we all good with that now? Okay, if it normally looks like this, when I flip it over the y, nope, that's if I flip over the x. We're gonna flip it like this. Let's look at it. It's gonna stay at this point right here. And instead of starting low and ending high, it's gonna start high and it's gonna end low. I have no idea what it is. Same point, it's gonna start high and it's gonna end low. Sorry, flip-ins are really weird, and I promise I was like trying to be very intentional, and then we all got tripped up. So I'm so sorry that that happened, but we flipped it over like this axis right here. So instead of being like this, it's that new pink. Give me 2 seconds and I'll show you that.
Oh, so is that point at 0, 1, or is it 0, 2?
It's still at 0, 1.
What's the point of, does the two do anything to it?
The two affects how like steep or how unsteep it is.
Okay,
And so we're just sketching, so I just want you to kind of keep thinking about this e to the x. Cause I was not super strict on how steep or not steep that one was, so we were just still kind of keeping that same idea. Okay, now let's flip your paper over, cause Jonathan asked a really good question that leads us to that next problem. He's like, okay, well then what does it look like when we flip it over the x-axis? And I'm gonna tell you right now, that's what this negative does. And that's our normal flip, right? Our normal flip is kind of up and down. It's if it's on top, then I flip it to the bottom. So it's gonna be the same thing here. We'll still have our horizontal asymptote at 0, but instead of starting in like the second quadrant close to the axis and then going up in the first quadrant, we're gonna start close to the axis. So we're gonna start close to that x-axis, the horizontal asymptote in the third quadrant, and then we're gonna hit 0, -1, and then exponentially go down. So it's just mirrored over that x-axis. So it's not this one on top, it's just the one on bottom. See the difference between those two? Okay. Bless you. All right, I've just got one more, so Thomas, what's up?
How'd you get that 0.01?
On all of
Okay.
these, we've had 1, 0, and so when you flip it down, it just changes the y to be negative. So
Yeah, how'd you get it like at the start?
oh, that's just a point I know that's, Mhm. That's like, do you remember sine? I told you always starts in the origin. Or like x squared, a general x squared graph always goes through my origin. That's just a property of this graph. Mhm. Okay, now last one. This one is 0.5x plus 1. Okay, let's do the easy part first. What does that plus 1 do to my graph?
move it up.
Moves it up 1, good. Good, so instead of being at 0, 1, it's gonna be at 0, 2. And where's my horizontal asymptote gonna be? Instead of at 0, it's gonna be at. It's gonna go up to 1, it's gonna shift up 1 unit. Okay, now this 0.5 does do a little something to my graph. Can we think of that as 2 raised to some power is equal to that 0.5? Two to the -1, very good, because 2 to the -1 is 1/2, and that's the same thing as 0.5. So what this is saying is that 0.5 is the same thing as 2 to the -1, so that exponent is not just x, it's gonna be -x. And what did we say when we had a negative up there with our x? How did that flip? Flip over my y-axis like this. Flips like this over my y-axis. So am I gonna start on this graph? Am I gonna start low towards the axis, or am I gonna start high, exponentially decreasing? High, and then I'm gonna end, am I going up again, or am I gonna go down close to the horizontal asymptote? Down towards that asymptote, good. Okay. That's all I wanted to do today. You guys killed it. Okay.